Okay, welcome back everybody to part 4. As you can see, I've got the front cover and the knobs back on, and I've done some of the voltage checks. I've showed you some of those, and so I feel like we're about ready to start working on the transmit side of it. The cool blue lights looking a little better on this video. On the camera, I haven't seen the video version of it yet. I've just seen it on the camera, but it looks a lot better than it did on the other because of the glass that we put back in. And I did take some of that Novus number 2 and go over that and got a few of the smaller scratches out. It wasn't that bad. It really, I could have probably put it in just like it was, but I felt like, well, I had it out, let's just do it, so I did. And that's just something you do while you're sitting there listening to the radio or something else. It doesn't take a whole lot of time to do. It's just a little elbow grease. I've started working on some of this stuff, and I have noticed one thing. I'm running about 900 and I can't tell you, it's plus 900 volts on the plate unloaded, and then when I go into transmit, it goes to just under 800, about 780 volts or so. It seemed like a big drop, but that's in its operating range, and so that's just something I've been trying to look and everything. I've already loaded this up, and the output is good, the current is good, and the voltage is in the range, so I think it's okay. One of the issues I see is when I have the meter on high voltage, that measures the high voltage on the plates, and that's the red scale, and that's 0 to 10, which it goes 0 to 1,000, and I'm only getting a little over 500 on this meter. Now, one of the things I've been reading about is on the HV, or the high voltage board, there's a series of it's a voltage dividing circuit in there that the meter takes a reading off of, and one of the common issues is a 100K resistor usually drifts and causes this meter to be inaccurate. So I'm going to go in and pull that board, look at those resistors, and change those resistors out as needed, so that the front panel will be accurate to what or close. This is a relative meter anyway. But you want to make sure the resistance on those boards and that metering circuit is correct, because that's what you're measuring current and voltage off of. Okay, this is the high voltage board. As you can see, basically a bunch of resistors. This is for the meter. This is the 100K resistor is here. No, that's not. It's underneath here. I saw that blue and realized that wasn't it. Yeah, you can see it here. Right here is the 100K resistor. We're going to definitely check that. Pull the schematic for the HV board out of the 520 manual, and looking on it, there's no R7. Okay. This is the R7 right here. It's a 12K resistor. Let me get another schematic out. Here's the R7. This is the schematic off of the Kenwood TS 520S I have a 520. But this is probably an updated. I've owned this, so I know that I didn't change this. Now this looks like a new resistor in it. I do not remember putting that resistor in there. This board is the board that goes into a TS520S. They probably updated it, and then they put it in this model towards the end of the 520, and then the 520S's started coming out. That's the only thing I could think of. But so we'll use the schematic, and basically what that resistor does, when you go to the tune mode up front, it drops the screen voltage to reduce the power, and it goes through that R7. So that's what the purpose of that is. Now the R5 and 6, which is, I believe, these two, R5 and 6, they change value, and it'll cause power level problems in the tune mode only. Let's pull this board out and check these resistors. We're going to, since this is showing low high voltage on the meter, I'm going to definitely check this 100K. We'll also check these two 56K resistors, and we'll check this 12K. But we'll check all of them. It's just such a small board. We'll check them all. I pulled the one end of the 100K resistors because it was in the circuit and I couldn't get a good reading on it. And when I pulled one end out, it was 98K. So that's close enough for me. So I started going up to these 680K resistors. Now they're all in series. This is the 520 schematic. It's got 3 of them in series, and then it takes the high voltage reading, which goes to the meter. There's a bypass cap, and so this voltage divider here, it's those 3 680K resistors, and when they join to the 100K is where the high voltage goes to the meter. Now that's the 520. This is the 520S. It does the same things. You can see the 800 volts comes in, goes through the resistors, and then this is ground, and here's your high voltage. That's the junction of these resistors with that bypass capacitor there. So I've been checking these resistors, 680K. Okay. The first one, I've lifted the lead on one of them. And I'll show you why in just a second. There's roughly 774K. That's fairly high. We'll call it high. I don't know. I can't do the math right off the top of my head. There's a 780K resistor. Should be 680, right? That's 100K more, so that's 1/6. That's over 20%. Now look at this one. This one's over 2K. So that's where the high voltage reading on the front meter comes from. So that's why my high voltage reading is low on the meter. So I have to replace these 3. I don't have any, so I'm going to have to order them. So I'm just going to put this back. I've only pulled 2 screws and lifted the ground on this board to to facilitate me getting into it. So I'm going to put it back, solder this back, and put it back in until I get the resistors, because it's not that big an issue. Now this resistor, I said, looked like a newer resistor. Got to looking on the back side. Looks like I changed that in the past. And apparently somewhere down the line, I can't remember it. I mean, that's the sad part. I can't remember it. I was getting low output in the tune circuit, and so I probably checked and changed those resistors. There's only 2 more resistors to check, or these 3 to check. I'm going to check those before I do any order. I think I've got a 12K, which is odd because that's an oddball, but I think I've got some. But I'll check these 3 to make sure they're all good to go before I make my order. Okay, going through here. The 12K is good. The other 56K was way out. Let's see how much it was. I said way out. It was like, it's supposed to be 56K, and it now reading 69K. So that's a little much. So I went ahead and changed it out. Now I've got to go order these, but I've put everything back so we can go on with other parts, and then we'll come back and we'll replace these resistors when I get those. Okay, here is the high voltage, which is the red. It's in, you multiply it times 100, 0 to 10. And so let's see what the high voltage, this is before I've changed the resistors. I know that there's some resistors bad, and it's showing roughly 500 volts or so. We'll change those and we'll see what it does when we change that. Okay, I was advised by some of the guys on the Kenwood hybrid group to check the voltage on the plate choke. And so I've checked it. I've got it on there, and it's right at 900 volts. Let me get it straight on, which is exactly where it needs to be. So I've been checking it at other places, but they told me to check it right there. So it seems to be in order where it needs to be. A few more resistors to check on the bottom on the cathodes to make sure that they're within tolerance, and also got to change the resistors on that high voltage board. Was able to get those in. So when I turn this off, lead the resistors, unplug it, not necessarily in that order, but then replace those resistors and see if the high voltage reading on the meter is where it needs to be. It's been reading right at that, right around that 5, that red 5 in the middle, and it should be up closer to the 9. So let's change those and see what we come up with. I've replaced the resistors on the HV high voltage board, and so double check my connections, and then let's flip it over and see if it changes my high voltage reading on the panel meter. Okay, I've replaced the resistors, and even though I'm reading 900 volts on the plates during non-transmit, when I do transmit, it does drop. So if you'll remember, I was reading right around 500, and now I'm reading closer to 800. So that is more accurate than what it was. So I think, and that's just a relative number anyway. So I think that's got that corrected. Here's the capacitor kit that I bought. There's the 4 grid and driver capacitors, which I bought from another source, so I can use those. Those are 400 and those are 22 microfarads at 450 volts. I can use those in my box. And also I've got several other, there's 47 different capacitors in this kit. Checking with the guys that repair these and talking to them, they said that what the capacitors that I've changed are typically the high voltage ones, the ones that commonly give the problem and will cause the most collateral damage if anything goes south on them. And in their practice, in their business, they do not typically change any of these unless they, during their troubleshooting and testing and alignment and what have you, do they change those. So that's the advice I'm going to take. I'm not going to change any more, and I'm going to go run through some more resistors and some tests on the rig as we bring it up in power, and we will change the capacitors as needed. Let's look and see where we're getting our specs from. Okay, this is out of the manual. These are the readings on the meter on the front, and you know, I was curious and I was checking other videos to see what other people were getting on there. But in the tune on the high voltage, they're getting, you should get about 800 volts, and we got just slightly under that. On the CW, which that was when we were keying it up, it shows about 750, and I was still getting about 780 if I remember correctly. Now on sideband, we haven't checked the high voltage when it's operating, so that is 800 volts. Okay, on the CW, your current, your plate current is limited to right around 200 milliamps. Now let's see where that comes from. Let me see if I can show you where the 200 milliamp limit comes from. This is on the TS520. Now the other models vary a little bit. This is one of the earlier models. Excuse me. In the specs, in the manual, is 160 watts for CW operation. You get 90 watts if you're on the DC power supply, okay? But 160 watts is the specifications for this transmitter. So each watt, or each tube, the 6146B, they'll have a plate dissipation of about 35 watts each. Okay. At full load, you're running close to 100 watts, okay? But remember, we have plate voltage of approximately 800, plate current at 200 milliamps or 0.2 amps. So if you do the math, 800, P equals IE, plate or power is equal to the voltage, which is 800 volts, times 0.2 amps. And that equals 160 watts. Okay? Now, since these tubes are configured in a Class AB1 amplifier circuit, the efficiency of those are about 60%, which means you take 160 times 0.6 and you get about 96 watts out on the meter, and that's about what we got. So it looks like this is doing what it's supposed to do. Now Where'd the other 60 plus watts go? It's dissipated as heat when the electrons are striking the plate. The tubes heat up, and that's why if you key down for a long period of time, the tubes get hotter and hotter and hotter and hotter and hotter, and we got an output fan on it to keep those cool. So that's it. That's where these numbers come from. So far, it looks like this is doing what it's supposed to. Let's check some resistors, some important resistors. Okay, let's check it. As you can see, we're running just slightly less than 100, which that will be, if we do the math, 800 times 0.2 is 160 watts, times 0.6 is right around 96 watts. And based upon whether your meter is correct or not, so it looks like this is doing what it's supposed to be doing. First things you want to do this is the final tubes under the bottom. You want to look at these resistors and capacitors and just look for overheating, charring, arc marks, anything like that. If you'll look, this is untouched for all those years, and everything looks really, really good. Okay, now these are carbon composite resistors. The first thing I'm going to check, these are 10 ohm resistors that goes on the cathode. These are cathode metering resistors, and basically what it is you have a resistor going to the cathode of this tube to ground, 10 ohms. Okay, over on this tube you've got another 10 ohm resistor going from pin 1, and you can see pin 1, let's see, it's 1, 2, 3, 4, 5, 6, pin 1, what's it? 4 and 6 are all tied together. You can see with the wire, they're all tied, and they go to ground through this resistor. Now, when you can't see, maybe, is there's a black wire that goes from this point to this point and ties these two together in parallel. So what are these resistors there for? Well, these resistors are there to they're metering. They're there for the meter. We're going to measure the current, basically the voltage drop across these resistors. Now, these resistors, since they're tied together, are now in parallel. So two 10s in parallel, and you do your Ohm's law, it's basically half of what the resistors are. So for this metering circuit to be accurate, it needs to be as close to 5 ohms as possible. Okay, these are carbon composite, and what happens to these, and I may have said it, I may not have said it, but what happens is this type of material draws moisture. Well, when it draws the moisture, it gets in there and starts corroding, and this resistor is just a piece of carbon stamped on these leads. Okay, it's crimped or molded onto these leads. Well, when the moisture gets in there and gets around those leads, it starts corroding. So when it corrodes, it increases the resistance. That's why these resistors typically go up in value, and a lot of times they'll go up, good rule of thumb is they're almost twice the amount in most cases. But so since we've got two in parallel, two 10s in parallel, we want this circuit to be as close to 5 ohms as possible. And that's pretty close. Okay, now if you look right here, there's a 3.3K resistor, and what that comes off of there goes to this little terminal block, little green wire, and that green wire goes to the metering circuit. So this resistor is important to measure. This is almost, it needs to be really, really close. And this is a 3.3K. So let's check it. We'll go across it. And so we are looking at 3.318K. So that's pretty good. It's pretty good. All right. Now we've got some bias resistors. These are 100 ohms right here and right here. These are half watt. These are 1 watts over here. But and these should be 100 ohms, okay? Or really close. And these are 10% resistors, 10%. And this one is reading 111 ohms, 112, okay? We'll change to the other one. And this one is reading 108 ohms. So that's within tolerance. The other one is slightly out. Do I change them? Yeah, I think I'm going to go ahead and change them while I'm here. I wasn't going to change them, but I think I just talked myself in, because once I button this up, I don't want to be back. And I'll probably catch a lot of grief because I didn't change the carbon composites on those also. But while I'm here, I'm going to go ahead and change these grid bias resistors. While I was editing this video, I got a phone call from the church. Some ladies had found a snake in the kitchen area, and so they called me to come and get it. So I went and captured it and took it to a local woods and turned it loose. It was just trying to come inside, getting ready for some cold weather. Okay, we've got these replaced. So let's pull it back a little bit. See if I can get a meter in the picture. It's hard to do. Get it all in one picture. Alright, let's put that in the center there, and we should be close to 100 ohms on each one of them. And that one is sitting at 97.7, which is within 2%. And there's one in 98.2 or so. So that's within 2%. So that concludes this. So I think that it's time to take this and put it in my Radio Shack and put it on the antenna and dummy load down there, load it up, and do some put it on the air and see how it talks. What do you guys think? Let's do that. Let's see if we can't do a little bit of this math. I'm going to check the voltage drop across those two 10 ohm resistors, which is basically 5 ohms. So let's say, and that's going through that metering circuit, it's measuring the voltage drop of those resistors, and that's calculating the plate current. And we're saying that the plate current on the front is showing 200 milliamps. Okay, let's do the math. So let's figure the voltage drop, which is E is equal to current times resistance. So in this case, it's 0.2 amps times 5 ohms, and that equals approximately 1 volt voltage drop. So let's check it. I'm going to put it in transmit, and we'll see. We're getting a 200 200 milliamp current plate current. So we should get 1 volt or so there. So let's see. 1.1, just slightly less than 1.1. So that's how that works, and that's one way to check to see if the meter's reading appropriately there. Got the covers back on the 520. I really like the cool blue. I'm got it tuned up. I'm running right at 100 watts on the meter. I have got a friend on the other end. He's going to give me an assessment of the way the radio sounds. Now this is not staged per stage. He's going to give me an honest assessment, okay? Alright, let's see if I can make this contact here. He lives down in Dayton, Tennessee, and that's probably 20 miles or so. This is middle of the day, 80 meter band, 75 meter band. Propagation's not the best in the world right now, so let's see if we can. Okay, that's him there. KJ4BJ, this is WA4PJP. How copy?
WA4PJP. KJ4BJ, copy you good. S9. I think the band's a bit long, but I hear you just fine here on the old TS530S. I'm running my big loop antenna, driving my L80B at about 1150 on the peak output. I guess this thing really drives my amplifier. I'm liking that, but anyway, thought I'd try that out for a little bit and then go barefoot and see what it looks like between that and barefoot during the daytime. But the old 520 sounding good down here, old man. Congratulations, you've done a good job. Go ahead.
Okay, I just wanted to make sure that it was clear and that had plenty strength. I'm kicking right at a little over 100 watts on peaks, and so everything looks good and is operating good on this end. Thanks for the response. And so I think I'm going to nail it down and run it for a few months and see how it does. Over.
Oh yeah, roger. Well, let's see. Let me look at my meters here. Hello. That's about 110, 115 watts here from the 6146s. That's barefoot. So how do you copy now?
You were before with the amplifier, you were running about 20 over. Now you're running just a little bit over S9. Over. Still very armchair copy. Over.
Oh, good. Then I guess that's working. Well, I just yesterday did my 6 month.
All right. So I think this is going to be good. I think we're going to end this series here. I'll give you any updates, any repairs, or any problems I have with it. So I appreciate everybody following me on this. I appreciate everybody watching. So from Larry, from the hills of Tennessee, thanks for watching.